Okay, let's take the geometric sequence now and put it into some applications. So the first thing we need to establish is the formula for the geometric sequence is Tn is equal to AR to the power n minus 1. Okay. Now there's a lot of variations on this. Like the compound interest will be A is equal to P times 1 plus R on 100 to the power n. Okay, and it's applying the same thing where A in this case is P, R is this value here, and the power is this power here. You will also find variations like population is equal to A times R to the power T minus 1. And there are others. Okay, so let's have a look at this context. We have the population in a town in the first year is 10,000 and it's decreasing by 10% per annum, that means per year. We need to find the population when t is equal to 10, so that's after 10 years. Alright, so let's establish our formula first. So in the first year, we'll call this t, the population was 10,000. So if it's decreasing by 10%, I need to take this 10,000 and times it by 0.9, and I'll get 90% of that 10,000. And that'll tell me what the population is after the second year. In the third year, okay, so let's actually calculate this, and we get, take off 1,000, I'm going to get 9,000. All right, so now my population is 9,000. If I take off another 10%, I'm basically taking that 9,000, which is that there, and take 10% off again, I'm going to times it by another 0.9. And so when I take off 900 from 9,000, I get 8,100. Okay, so in the fourth year, I can copy that and paste it, because that's my 8,100. And if I want to know what the population is in the fourth year, then I need to times 8,100 by 0.9, and that'll give me the answer. Now, I'm not really interested in what that value is. What I am interested in is establishing the pattern. So if we want to know what the population is, then let's call this T, and the population is basically 10,000 times by 0.9 and to some power. Well, if T is 2, this is 0.9 to the power 1. And when T was 3, we have 0.9 to the power 2. And when T was 4, we have 0.9 to the power 3. So basically, this is when we have T here, we're going to have T take away 1. And that's our formula. So we can now solve for when T is equal to 10. And we're going to say P is equal to 10,000 times by 0.9 to the power T take 1. 10 take 1 is 9. And you have it. So typing that into our calculator, we get 3,874 people. And that's it. Let's try another one.